Good morning, everybody. I'm going to be talking about parsers, and I'm going to be talking about exploits. So the title of my talk is Generate Parsers, Prevent Exploits. But it could also be called Langsec for Ruby devs, or, hey, theory of computation is actually relevant to web development. Well, maybe. So what am I talking about? I'm going to explain what exploits are, and talk about how they relate to formal languages, and then talk about how you want to generate parsers to deal with those formal languages, because that's awesome. And also, there will be pictures of ducks and geese to sort of represent, it's like duck, duck, deuce. Good, good, bad. All right, so exploits, they suck. Having an app exploited totally sucks. It ruins your day. Attackers, they get access to, they find holes in your application, and holes in your castle walls, cracks in your dams, various other analogies. It's kind of hard to explain. And when they do that, they end up getting access to all of your stuff. You get your secrets, they get access to your database, shell on your servers, root access, everything. And that sucks. Oh, as an aside, make sure that your passwords are hashed and salted correctly, because you don't want to be, you don't want those to be unfortunately exposed. So, exploits, like when you think about them and you're looking at lists of them, they sort of feel like these tricks, like, oh, well, if you do this special thing, then suddenly everything goes wrong. And they feel like it's hard to anticipate where they're going to show up. Like, how do these things even work? And they feel like they're unrelated. I mean, what do buffer overflows and SQL injection and cross-site scripting and everything else have in common? They sort of feel all different, but the truth is that they're not different. They're all the same thing. They're unexpected computation. Somewhere in your application is some control flow that's going to run that you didn't really intend it to run that way. And computation is an interesting word because, hey, that means that we can use theory of computation to think about exploits. So we're going to hand wave about that, but not yet, because we don't need to talk about that just yet. So exploits, they're not tricks. Exploits are machines. And what do I mean by a machine? Well, they're a computational machine. So they do the same things that, like any computational machine do. They take input, they do things with that input, and then they produce output, and maybe profit. So it's basically the same as any regular program. I mean, like when you're making a Rails app, you want to take input, do stuff with it, and produce output, and then make money. It's great. And that's the same thing that people trying to use exploits are doing. But what's different? So the thing that's different about an exploit is that it's made up of a slightly different set of components than your usual machine. There's got to be undefined behavior in the application that you're looking at, and there has to be some way of talking to that undefined behavior. Exploits are living inside applications and frameworks. And the way that they get input is through those applications or frameworks inputs. So you can kind of think of an exploit as not just a machine, but a weird machine, because there's this level of indirection where the exploit is receiving input through this thing that you didn't expect to happen through the inputs. And weird machine is actually the term that some people in the offensive info security community use to refer to these, because it sort of feels like you're programming in this really strange language that's accepted by a very strange machine. So I made this neat little diagram. So like if your app has an exploit in it, what's going to happen is an attacker is going to send input to your application, but really it's going to go to the exploit, and then output can come out of that. So it'll hit the boundary of your application. And instead of going to the code that you expect it to do and computing the thing that you want it to compute, it's going to go somewhere else, and it's going to end up at the exploit. And then it's going to come out, and the attacker is going to be able to see effects from that, and they're going to be able to infer what kinds of operations they can do with that particular exploit. So how do you stop these things? Well, the answer is relatively straightforward. You need to break their communications, because if your app has undefined behavior, that sucks. But you can actually, if you get rid of the ability to exercise the undefined behavior, then it's not behavior, it's just something that's in your code, and whatever, it's dead code, which is safe. So what we need to do is we need to validate our inputs before we use them. So let's talk about what that input is. The input is instructions to the exploit. And remember, an exploit is a weird machine. And so you can think of the instructions as being basically a program. And it's a program in the language of the exploit. So if you had a SQL injection in your application, it's sort of like writing for a machine that takes SQL as its language. So let's talk about an example. So last year, Rails had this bug in it where it would, when you had XML that you were trying to parse, it would take that XML, and if it had a special little thing in it, it would read that text as YAML, and that was a bad idea. And the reason that was a bad idea is because YAML, you can get access to any class. You can create an object of any class that's in the runtime with the particular YAML that Rails was using. So if we look back at this diagram again, we see that the input comes in, it goes to Rails, goes through the XML parser, and then there's this undefined behavior inside the XML parser where it's parsing YAML. And we didn't, you don't think, oh, YAML, that means eval, but it does. So that's not good. So the way that worked was you'd have this weird crafted input where you'd have like a XML document, and inside that you'd say, oh, the type of the contents of this is YAML, and it'd have some evil object that exists in the Rails runtime that allows you to do eval. And once you did that, if you were an attacker, you would be running Ruby on whoever's application that was, which is terrible if that's your application. So that's a big sad face. And, like a big angry goose is like, ah, this is terrible. Watch out, the goose is going to eat you. And so if you haven't patched that, I would really strongly advise that you patch it because it's in Metasploit. People can just sort of run a script and use it on your applications. So what's the real problem here? The real problem is bad input validation. And the way that you deal with that is pretty obvious. What we want to do is we want to have good input validation. We don't want to allow bad inputs. Like if an input is bad, we don't want our application code to even see it. We want it to just go away. We want to say like, that's rejected. No. But how can you do that? The way that you do that is by recognizing inputs before you process them. And so that brings me to LangSec. Earlier I said one of the titles of this talk is LangSec for Ruby developers. So LangSec is actually short for Language Theoretic Security. And so this is a field in InfoSec where you take theory of computation and an understanding of formal languages and you apply them to securing systems. Because it turns out that if you do, the things about formal languages allow you to make certain assumptions, and you can say certain things are secure and certain things aren't. And that's very interesting. And so I watched this talk on it like 2 years ago, and I was just like, this is amazing. More people need to know about this. So anyway, this last thing that I had up before, this is actually one of the things that they say you should do. This is important. If you don't do this, then you're exposed because you could end up in undefined behaviors. So that's just ducky. But recognize, that's an interesting word. If you've taken a compiler's course or theory of computation, you know that recognize is not just, it has a specific meaning inside computation. So what we're actually talking about is decidability. I mean, this question of, can we do this? And indeed, that's what we're talking about. So we're going to crack open our Theory of Computation Handwave Edition. Yeah! So Chapter 0 of the Theory of Computation Handwave Edition is on decidability. And decidability is all about answering this particular question, which is, if you have a formal system or a formal language, is every statement that can be said in that possible? Is it possible to say yes or no to every statement that's in that? And so I would like to go to an example to explain the answer to this particular question. So this example is in a natural language that I like to call English. This statement is false. If this statement is false, then this statement is true, but then if that's the case, then it's false, and you just keep going. And since it keeps going, that has a relationship with the halting problem, which is the idea that if you have a Turing machine and some input, and you don't know anything about the Turing machine, you can't actually tell, given that input, whether it will halt or not. And that's important because if that input is input to your application, you want to know whether it's going to halt, because you want to know, usually we want to do something with a web request and then give it back to the browser. We don't want to just sit there indefinitely. That's not good. And it turns out that kind of thing is undecidable. So that's the first hand wave portion. So undecidable problems exist, but what does that have to do with input validation? Well, it kind of sucks. There are types of input that merely recognizing that input is undecidable. So if you try to parse something, that parse could just go forever, and it will never come back. So you don't want that in your applications. That's terrible. So the other implication of that is that if you want to make sure that your application doesn't have any exploits in it, if you accept that kind of input, it's impossible, provably impossible, to secure your application. So yeah, that's pretty bad goose there. It'll make you run around the circle. So certain types, that's kind of fun. Let's go back to the theory of computation hand wave edition. So if you've ever taken a compiler's course, you probably know a little bit about formal languages. But if you don't, that's okay too. So there's this thing called the Chomsky hierarchy, which describes the complexity that's allowed within certain grammars. So the biggest one contains all the other ones, so the other ones are all smaller. And so I'm going to start from the bottom. So regular languages are boring languages. If you ever use regular expressions without the extended regular expressions, regular expressions defines regular languages. And that's why you don't want to use it to parse XML, because you can't do things like match parens, you can't handle nested stuff. But you can do stuff like, I'm looking for a bunch of these things and then a delimiter. That works. And you also can't count things. So you can't say I want n of these things and then the same number of this other thing. You can't do that either. And so that's just ducky, because it's a pretty boring language and it's pretty safe. Context-free is a little less boring because you can now represent nested structures. It still has all the same powers as regular languages, and they're pretty nice languages. JSON would be an example. So that's also pretty ducky, but it's not as cuddly because it requires more processing power in order to handle. Context-sensitive languages are less boring and mostly safe. So all those other languages, you can recognize them, and that's a decidable thing. You'll know that it'll terminate. Your parser will terminate. With context-sensitive languages, the parser will also terminate, but it's a lot more complicated because you can do things like you can represent how you're going to parse something within the language a little bit. So you can say have a field length and then have the field. So you can there's this protocol called message pack where you say I have a string and my string is 60 bytes long. So you look 60 bytes and then the parser can just skip ahead and find the rest of the string. So you can do stuff like that. So that's a duck, but it's not as nice of a duck. Recursively enumerable, however, which is the biggest circle, is it's a terrible class of language to use as input because you can use recursively enumerable languages to describe Turing machines. And if you can use it to describe a Turing machine, then if you have a parser for it, it's kind of like having an interpreter for Turing machines. And so that runs back into the halting problem, and that's not great. It's no good. That's not good at all. So that's the Chomsky hierarchy. So I talked a little bit about the recognition qualities of that. So for recognizing things, everything below recursively enumerable, which sometimes is called Turing complete, those are all safe. If you have those and those are the things you're parsing, you're pretty good. But there's another quality to these languages, which is that there are also decidability questions about whether you can compare two implementations of a parser for a language. And it turns out that has a kind of a funny place where it breaks apart. So So if you're using recursively enumerable input, you know, like you're SOL. Context sensitive or below, it's okay. But if you're trying to compare parsers, well, so it turns out that context free is actually broken into two pieces, deterministic and non-deterministic. And I'm not going to get into what that looks like, but things like JSON are deterministic. So if you wanted to compare deterministic context-free parsers and tell whether they are equivalent, so like say you're writing a standard and you want to say like, I want all parsers to conform to this set of specs. With a deterministic context-free language, you can do that. It's decidable. Duck. Okay, so there was a little bit of hand waving there. That was kind of complicated. Let's take a break. This is the things that you can parse and compare the parsers of is actually pretty small. So that's good if you can keep to those languages. So let's go back to the thing that we were just talking about, recognizing inputs before processing them. This is actually one of the things, like I was saying, this is one of the things that langsec tells you to do. The other thing that langsec tells you to do, and the reason why I talked about comparing parsers, is that if you use deterministic context-free languages as inputs, then like you're safe. You can always say like all implementations all work the same, but you can't do that with anything with an input grammar that's more complicated than that. So that's not good. Langsec also has a bunch of things that it says don't do this. Like seriously, don't do this. So the first one is turn complete inputs. If your inputs are turn complete, then you are accepting a programming language as input, or you're accepting something that is incidentally effectively a programming language. And neither of those things are good things. So like for instance, if someone is trying to sell you like a network box and they're like, oh, the command language for this includes programming languages, so it's extensible. Yeah, don't do that. Run away from that. Then you also don't want to do ad hoc input validation. And what I mean by that is you don't want to like smear parsing and validation of the things you're parsing across your application. Mostly in Rails and Ruby, we don't have to worry about that because Rails like sets up nice structures for handling those kinds of problems. That's also known as shotgun parsing if you're interested in looking that kind of thing up. And then the other thing is that you don't want to use parsers that are weaker than the language that you're trying to parse. This is the classic don't parse XML with JSON with regular expressions, because regular expressions describe regular languages, and XML is not a regular language. So if you try to do that, you will end up in an unexpected state in your program. So if you're trying to validate that the right codes are being sent and you use a regular expression, you will fire the missiles. TLDR, use JSON. It's deterministic context-free, and it's mostly okay. So as far as Rails goes, Rails actually does some pretty neat stuff. So if you look at Rails' HTML sanitization stuff, they don't try to do something silly like use a regular expression to look for script tags. Oh no, they actually have a tiny little XML parser that will parse the data and strip out the tags. And that way you don't have to worry about attacks that deal with like escaping things strangely and stuff like that, which is great. But I do have some qualms about it. So I feel like Rails parses things too early. And the reason why I feel like this is because Rails parses things inside Rails before it gets to your application. It's like, oh, the MIME type is XML. I will parse that, put that into the params hash, and then when you get to your controller, you can use that params hash, and that's great. Or if it's JSON, same thing. And I feel like that's not great because your application is the thing that understands your application's input language. And if you want to treat your input language as a formal language, you have to do all that stuff in the same place. So I feel like we should be doing stuff more like this. And because what the goal is to remove undefined behavior. And when Rails is parsing things for you, you may not even use that input. Someone could, like you have just a show page. That show page could, potentially accept query params. Or if you have a post, that post might, like you may or may not actually do anything with the body. And if you don't do anything with the body, I feel like you shouldn't, Rails shouldn't even try to parse it. And so that's why I feel like we should do our parsing in application land instead of in Rails land. Because what we want to do is remove undefined behavior. So we don't want to allow undefined inputs. What we want to do is only allow defined inputs. And this comes from the LangSec. So the idea is like, back in the olden days, you wanted to say, well, I'm going to be liberal with my inputs because I want to make sure that everyone who tries to talk to me, I'm going to try to do something reasonable. But the problem with doing that is that your inputs aren't definite. And so you end up making these kind of strange machines. And this ends up in this situation where you have these ad hoc parsers that have all these unexpected computations available to them. So what you want to do is you want to treat your inputs as formal languages, and you want to treat, and by doing that, you're treating computation as a privilege that you aren't giving out to random people on the internet. So defining inputs, isn't that kind of a pain? Yeah, it is a pain, but we already do it to a certain extent. I mean, Rails has input validations. I talked about some of them already, but the ones that I think we interact with on a more day-to-day basis are things like attr accessible from Rails 3, which was okay, but what it did is it would check the inputs like right before the model. And the problem with doing, so that's good because it constrains all access to the database, and it blows up on bad keys, so like you get errors when someone sends you bad data, but the place where those accesses are controlled and the place where they're used is in different places, and use case handling is a little weird. So Rails 4 added strong parameters, which I thought was great because it allows you to put your validations right next to where you're using those inputs. And that's good because you're doing validation. And so that moves validation a little bit further towards where you're parsing. But I feel like you could do even better than that. So the pros of that is, like the usage in the same place. The schema allows nesting, which is nice because, like we accept nested JSON and nested forms, so that's great. But the things I don't like about it is when you're using it and you see like this permit thing, that will, if it sees something it doesn't understand, it strips it out. So it's not accessible to your application, which is good. But it also means that if someone's trying to talk to your application will accept their input, but it will ignore it, which means that you have undefined behavior. And the schema is a little bit ambiguous, but I think that's okay for what it does. But why wouldn't we do that earlier? I mean, we could do input checking right between bytes and creating the Ruby objects that we then use to build, like to talk to our database or make web requests or whatever your application wants to do. And so that was the idea behind this library that I've been starting to work on, which is called Muskox. And it's Muskox because it's a parser generator, so it's like Yak or Bison, but Muskox because it's beefy. So it's a schema-based parser generator. And the current implementation looks kind of like this. So you can include it as a module, and it'll define some methods, and then you can add a parser with a particular name, and you give it a schema that's related to the JSON schema. And then that way you can strongly specify the types that are allowed of the properties and the kinds of objects that you're expecting to allow as input. And then it will only allow valid strings to be parsed, and it won't even create hashes if things are invalid. So, like you create a parser, then you can parse it, and if it works, it gives you back some nice data. But if it doesn't work, it gives you back an error, and it tells you this was the unexpected thing that I found, and these are the things that are allowed at this level of the input language. And it's structured by breaking a parser into two pieces. So there's a tokenizer and a validator. And what the tokenizer does is it recognizes the language, in this case JSON, and then it passes the tokens to the validator. And what the validator does is it takes the schema that you provided, and then it uses that schema to ensure that everything is safe, and then it populates the Ruby objects for you. I haven't gotten around to making a Rails extension for this yet, but that's kind of what I'm working towards. And what I want to be able to do is to replace usages of strong parameters in the Rails parser infrastructure that happens upstream of your application with code that looks like this. So I create a DSL for Muskox that sort of wraps it and abstracts some of that schema generation, so it looks almost the same as strong parameters, but works a little bit differently because it won't allow you to be ambiguous. There's a lot of work left to be done on it, so I would like to make it so that you can swap out form data processing and XML processing and all of the other kinds of interesting inputs that Rails applications and other Ruby applications tend to receive from the internet. Because I feel like the validator backend part could be used for anything that you expect to turn into hashes and arrays. So if you want to learn more about langsec, you can go to langsec.org. There's a lot of links to good talks that go into a lot more depth than I did. And if you want to check out Muskox, it's on GitHub.
All right. Good job, dude.